Hey guys, Mr. Bowman here. Today's learning objective is in red and we are learning to analyze time series graphs. Before we get started, the really important part of time series graphs is just understanding what they look like. And when you understand what they look like, you'll be able to apply the right skills. So in a time series graph, our x-axis will always have some kind of units of time. And these units of time, it might be, days of a week. It might be months in the year. It might be something called quarter one, quarter two, quarter three, and quarter four. And that represents January, February, March. And then we've got April, May, June, and then the next 3 months and the 3 months after that. It could just be years. So it could be 2012, 2013, 2014, etc. And the other axis, the y-axis, the y variable is just another variable that you're tracking to see how it changes over time. Example of a time series graph here. But before we look at it, I've got an abbreviation that I want us to help remember. So when you're like, oh geez, what can I use to talk about time series graph? The abbreviation TSN is a good way to help you understand it. So the T stands for trend. And the trend is when perhaps you have a line of best fit. And really you're checking if you look at the start and finish points, you'll be able to make a determination. Is it on average increasing over time or is it on average decreasing over time? So if we have a look at our Yellowstone National Park, you can kind of see, if you look at these peaks over here, this is a good indicator for me. You can see that looks like they're slowly going up. So a line of best fit in terms of an average might end up kind of sneaking in the middle through here. So in our graph, we can see there's a very, very slight increase. So perhaps when we're talking about T for this graph, we're going to say a slight increase. Then looking at S over here stands for seasonality. And seasonality is an interesting one. It's any patterns that we see within a year. Oh, spelling patterns wrong. Patterns within a year. And this graph here is fairly clearly, so we can see a typical year kind of starts. So there's the first 6 months, and then it carries on for our second 6 months. So that's a typical year. And you see this largely resembles this, which largely resembles this. So we can see it's a repeating pattern. And every year, we can see it's very low in January. And we can see that down the other side of our graph as well. So they're both very low in January. And they tend to increase into a peak, and then they decrease again after that. So in terms of our seasonality here, we're going to say it's got its lowest in January, and then it's got its peaks, and it looks like July, but I'll write June/July. So we can see that exact same pattern having occur every single year. And the last letter we need to be aware of, the N stands for noise. And this is any kind of randomness that goes against the trends that you're seeing, against the trends or the seasonality you've seen. And in our case here, noise, can we see anything? Potentially, there's not much noise happening because you can see the pattern happening the same. But if you have a look at the temperatures at the top here, we've got a weirdly high temperature at that particular point, but I wouldn't say that's noteworthy. So in this case here, we have no noise. Noise part a bit more. I've put in another graph here, and what we can see is our graph is slowly increasing, kind of in this area here, and then this nightmare happens. Not sure what happens here, but between 2005 to 2010, whatever data we measure, something's happening. And potentially after that, what we could see is here, well, it could carry on. It could resemble the trend as if that didn't happen there. So this noise here, it relates to the trend. It really goes against it, sharply increases, and then it sharply drops, and then it increases again, back to kind of where it should have been. So that's an example of noise, and we didn't have noise present in the Yellowstone National Park example that we looked at. So just going to delete this one to get back to our original graph. Last thing I want to talk about for this video is, well, what differentiates an okay answer, a good answer, and an excellent answer? So an okay answer, that will include statistical claims. So for example, I see the Yellowstone National Park number of visitors per month has increased. So that's the claim. A good answer, or a better answer, it will use statistical evidence. So how can we, with numbers from the graph, or written claims, statistical evidence, with numbers or observations from the graph, so numbers / observations, with numbers or observations from the graph, how can we support that claim that we just said had it been increasing? And finally, an excellent answer, a really, really good answer. And I always say a good answer, it tells us a story. And this relates to the context of the scenario. And a good example of here is seasonality. So a okay answer will say there is a maybe the number of visitors are the highest every June or July. A better answer will maybe mention, well, they're at their lowest in January, and perhaps they'll mention that it increases in between those high points and low points. In terms of evidence and numbers from the graph, maybe they're going to use whatever number this is here. Maybe they're going to use the dates to help support those claims as well. A really good or an excellent answer, it's going to tell you a story. It's going to start from the beginning of the year. So it's going to say, well, in January, the number of visitors are at its lowest, probably because it's winter in America and it's really, really cold in the Yellowstone National Park. No one's going to want to visit. So I'm telling stories. As the temperature increases, we see that the number of visitors increase. Eventually, we get to a peak of visitors in June or July. And perhaps this is related to the American summer school holidays, the summer break that they have over there. So again, you can see I'm relating it to people. I'm telling a bit of a story about what's happening. And then we can see, well, as the summer break finishes and the temperature declines, the number of visitors decline with it. And then during December, when it's cold, when it's winter in America, those visitors have stopped again. So I've told a bit of a story and I'm narrating what's happening in a typical year. So that wraps up this video on time series. The big thing I need you to remember, TSN, it always gives you a couple talking points you can talk about for these time series graphs.